All right, 8.3. All right, so for 8.3, we're going to learn a bunch more vocab, really. So here's the idea: we have things called a major and a minor arc that we can. It's called inscribe in a circle. So when I say the word inscribe, what I mean is if we had like point C to point B there, what we can do is you can draw like a line around the outside of the circle, and that'd be called like inscribing in the circle. Okay. If you inscribe in the circle, what can happen? You can get two different things, right? Like, so if I got point C and point B, then what we can have here is you've got a minor arc, it's called. So you can see that it forms like the shape of an arc. The smaller of the two would be the minor arc. And the larger of the two, so that one, would be the major arc. Okay, so it's the line going all the way around the outside of the circle from one point to another that's being inscribed. So one's the major, and one's the minor. Bigger one's major, smaller one's the minor. Okay. All right. Now, oops, someone wants in. So now, two different angles can be formed by joining the endpoints of the arc to make a chord, right? So what can happen here is, so if I've got, C to B, then you can see that I've got my minor arc and, my major arc on the top that are formed. And you could form a chord, right? So remember, a chord is a line that just from one point to the other. We did that in 8.1. The next one here is called a central angle, and a central angle is going to form from joining 2 points. So if I've got point C and point B, and then I draw a line from those things to the center of the circle, then what that's going to be called is, it's called the central angle. It's the angle that's happening in the center of the circle, really, right? Okay, next one. Again, from point C to point B, if I drew a line to any other point on the circle, so in this case it'll be to point A there, then it's going to make an angle in between those things, and that's called an inscribed angle. And it can be anywhere on there. So if I drew a different circle, so a different circle, and that's not right. I need to draw. Draw a circle. Sorry. Oh, wrong color. Okay, so if I had point like here and here, let's say, right, then the inscribed angle could actually be in quite a few different places. You could make the inscribed angle, there to there, right? This would be the inscribed angle, but it would also be considered the inscribed angle if I went from, let's say, there to there. That would also be what's considered the inscribed angle, right? So there's tons of different ways it could be from there to there, anything along the outside of the circle there. Okay, so going back, you can make a chord. You can make a central angle by going from that point to the center, or you can go to any other point on the circle and then back again, and then that'd be the inscribed angle. Okay, it's all just definitions at this point, but what we're going to start doing is doing a little bit of math with these definitions. So, so the inscribed and central angles of a circle are said to be subtended by the minor arc. All right, so another word, right? So there's lots of vocab in this one. So subtended just means that they're like bound to these 2 points, right? So if this is the minor arc, it just said there, right? This is my minor arc. It just means that the central angle, so that one, right, is subtended, you would say, by the same 2 points as the what do you call it? The inscribed angle on this one, right? So they're subtended by the same 2 points. It just really means that they're bound by the same 2 points. Okay. All right, now here's the meat of it. We're going to have 3 properties that we're going to use to solve problems here. So property number 1 is that if I've got 2 points, right, so they're being subtended by the the minor arc there, or by A and C, those points. If I drew a line to the center point, so there's my center angle, so that would be 60 degrees, then the line or the angle that's subtended or that's inscribed by those same 2 points is always going to be half. So you can see that this one's 30 degrees for that one. Well, this one, the central angle would be 60. It's always going to be double. And that's going to be the case if it's like straight up and down looking like a Star Trek symbol. If any of you guys watch Star Trek, maybe not. It would be the same case in that one, but it would also be the same if you had like a bunch of different examples here. So let's say it was from like there to there, and there's my center. So let's say my central angle here was 30 degrees. Okay, well then anywhere that I make these 2 points from these 2 legs, right, that I have on here, let's say that I made it from here to here, right? So these are both subtended by the same 2 points, right? They have the same legs, I often say. They're like stuck to the circle in the same spot. Anybody want to tell me in the chat what that angle would be right there? $15 is correct. Yep, perfect. It's always going to be half, right? So that would be half. The hardest part about these ones is actually just seeing it, I think. Because like you have to actually like notice that, these legs are the same for both of those angles. But just look back to your notes, right? Like look back to these properties and just see if you can, make sense of them. The other one that can be a little bit tough sometimes would be if the circle was upside down, I find. So just careful in these, because if the circle, that was weird. I guess that wasn't really a circle, was it? Let's say you had the same type of question, but it was something like this, right? This is actually the same thing, but it's kind of harder to see for some reason because it's upside down. So there's my central angle, and there's my inscribed angle. So this could be like 30, and that would be 15. Okay. All right, so that's property number 1. Property number 2 is that it's the same angle. Here, you can look at these pictures. I'm gonna make my own again, just to kind of clean it up here. So let's say we had our circle, and here's what property number 2 is saying. So it says in a circle, all inscribed angles subtended by the same arc are congruent, the same. So congruent means the same. What that really means is that if I've got these 2 points, right? So I've got the same legs, or they're subtended by the same 2 points. They've got the same minor arc, is what the definition there said. Then if I drew a line from there to there and said that this was, let's say, 30 degrees, well, then it would also be the case that if I drew a line from there to there, this would also be 30 degrees. It doesn't actually matter where I inscribe that angle from these 2 legs. It's always going to be the same. Even if it was from like, let's say from here and then back down again, that would also be 30 degrees. So it's the same angle no matter where I go on that. Okay, that's the idea there. This picture is showing the same thing, right? So it'd be from those 2 points, this is 60, and that is 60. It made it a little bit confusing because I could look at it upside down too and say, okay, from this point and this point, right? If I drew a line from there to there and a line from there to there, then if that's 30, then so is that. They just did it kind of twice there, so. All right, last one, property number 3. Okay, property number 3 actually is the same thing as property number 2. It probably shouldn't even get its own, but it just kind of is a easy thing to kind of, when you see it, you can just know it right away. But here's the idea. So they're saying if you've got your 2 points, right, the minor arc there goes all the way around, and it's actually half of the circle there. So your chord is actually splitting this thing right down the center. Then what'll happen from there is that if I subtend 2, or if I inscribe an angle subtended by C and B there, so drew a line from there to there, that will always be 90 degrees. It doesn't matter where I draw that line. So I could draw another one from, let's say, here to there. that would also be 90 degrees. It doesn't matter where on that circle, it's always going to be 90 degrees. But the reason why I said that's the same as the last one, really, if you think about it, is because if I think about what my central angle is there, my central angle is 180 degrees, right? So because that's going from this one to the outside, it's going exactly to 180 degrees. Okay, well, rule number one there said that the inscribed angle on the end is always going to be half of that. So that would be 90 degrees. So it really is, this one's just a combination of the other two. It's just kind of a special case. Okay, so that is 8.3. So let's just do a few questions here now. Here, you know what? I'm going to pause it. Oh, Google thought I just said something to it. Okay, so what's the value of angle X? All right, so some of you guys said in the chat there that yes, it's 100. And we know it's 100 because here's my legs. Oh, and they disappeared. Okay, there we go. There's my legs, right? They both start from those 2 points. So I could draw a line from that one to that one, right? They're subtended by those same 2 points. Well, there's my central angle. There's my inscribed angle. And property number one said that the inscribed angle is always going to be half of the central angle, right? Okay, next one. What's the value of angle A? So this angle. Okay, so this one's going to be a little bit more thinking. Not too bad, though. What we have to look at here, so property number 3 would say, property number 3 would say that, well, this line right there, right, splitting this thing in two. Okay, well, from that, I know that's a 90-degree angle, right? So then if that's a 90-degree angle, and they told me that this is a 55-degree angle, okay, a little bit of trigonometry here. We have to remember that all of the angles in a triangle add up to 180 degrees, right? So from this, I can say, okay, well, 180 degrees minus 90, which is just 90, minus 55, the last angle, what I have left there is just going to be 35 degrees, right? So that has to be 35 degrees. Okay, now what is the angle? What is the value of angle B? All right, so looking at this one, I'm trying to get my bearings on this. Well, can you guys see the legs? See it right now if you can find, there's actually 2 sets of like places that I could call my legs in this case, or like where it's being subtended from, right? I could do this, and this is probably what most of you did. This is what I did my first time, was I said, okay, well, maybe those are my 2 legs. And I could say, well, okay, from there to there would be like one of mine. And from there to there would be the other. But then I'm looking at that being like, well, I don't know what that is, and I don't know what that is. That doesn't really help me. I don't really have enough info. This is one of those cases where I was saying that it's actually a little bit harder to see. And the reason why it's harder to see, I think, is because it's upside down. So I'm going to make A and B my 2 legs in this case. So I'm going to say, okay, well, from here to here is one of them. And from here to here is the other, right? Then in that case, I can say, okay, well, if that's 32 degrees, then property number 2 that we learned there said that any inscribed angle subtended by the same 2 points will always be the same angle. So what we can do from that, I can say, okay, well, if that's 32 degrees, then that is also 32 degrees. All right? And then, okay, so then from there, I can see that I've actually made there's a triangle that's being made out of this, right? And I know 2 of the angles in that triangle. You probably see where I'm going from this, right? Then 180 minus 85, right, that angle, minus 32 is 63 degrees. Okay, so then that would have to be 63 degrees, right? These are actually kind of fun, right? They're kind of like little puzzles that you go through. I find them fun anyway. You guys are all kind of smiling like it's probably not that fun, but all right, let's do. I never had this one on here. You guys don't have this one on your notes, probably. I'm going to do this one just to kind of show you like an example, maybe of a, I don't know, like a little bit tougher one, where they want us to find angle X and angle Y. So you can draw this one if you have a room there, or maybe just follow along with me since you don't have it on your sheet there. But here's the idea. So I'm looking for, let's say that one first, right? And little hints here I'm thinking is that, okay, well, that would be a central angle, and it has legs at points A and B. Okay, so I'm like, okay, well, maybe something to do with that. And then is there any other, from those 2 points? Well, those are also the legs, let's say, of this one. Okay, well, so that's starting to give me a little hint here, because I'm like, okay, well, I could figure out what X was, or what the angle there was, if I knew what that was, right? Because X would be double this. Whatever this one is, X is double, right? That's our first property there. Okay, well, is there any way I can find that angle? Well, there's a little trick here where, and here's the idea. They've given me a straight line from there across. Well, what I can do there then is I can say, well, if that's a straight line, then I know that it actually is 180 degrees all the way around, right? It's 180 degrees from one side to the other in that thing. Okay, so if I know that that's 180 degrees and that there is 125 that's been accounted for, then I really should just be able to go 180 minus 125 is equal to 55 degrees. Okay, so now that I know that that is 55 degrees, then I'm pretty good to go for X, right? Because remember, that inscribed angle, here, I'll clean this up so you can see it a bit better. So this is 55 degrees, right? And there's my inscribed angle, and there's my central angle. Okay, well, my central angle is just double that, right? So X is going to be equal to 2 times 55, right? So X is going to be equal to 110 degrees, right? So it's going to be double that. Okay, so there's X. Now, how can we figure out Y? Well, here's what we're going to do. So if I know that this, right, is 110 degrees, and if I'm looking at this triangle here, and I know that that triangle, right, all the angles would add up to 180 degrees, well, let's get our bearings here. I know that this angle, those 3 angles, this one, and this one add up to 180. Well, what I'm going to do here, I'm going to go 180 minus 110, right? So what I have left here is 70 degrees, right? So I've got 70 degrees. Well, what that means then is that this angle and that angle they must add up to 70 degrees. That's what I have left. Well, the thing about this is, looking at this triangle, you can tell, right, that those 2 angles are going to be the same. And that's always going to be the case when you've got these lines that are, the same 2 legs and toward the center and then back down again. You can see that what I've made here is a isosceles triangle. That side and that side are the same length, right? And in an isosceles triangle, you're going to have that angle being the same as that angle. Okay, so I think you're probably getting what I'm saying here. So this one and this one would give you 70. So if I want to just get one of those angles, I'm just going to go 70 degrees divided by 2. So Y is going to be 35 degrees. Yeah? So that's kind of the idea. They do get a little tougher, right? Like on this one, there's like 3, sometimes 4, well, not 4 steps usually, but like, 2 or 3 steps sometimes to get the answer. So that's it. You guys have the formative to do for 8.3. The formative, though,